Hopefully all of you have some familiarity with AMF or want to get more familiar with it, or if you've ever tested an application that's used AMF to communicate, then you're probably here to make your life easier. Thanks.
All right, welcome. That was made my job pretty easy. Thanks, Nathan. And I'd pretty much like to introduce, for AMF Testing Made Easy, Luca Carettoni.
Thanks. Thanks a lot. Thanks for being here. Black Hat has been a blast yesterday. I hope you're gonna enjoy today as well. And hopefully, my talk is gonna give you something good. Today we're gonna speak about AMF testing, and in particular how to improve efficiency and how to speed up testing of AMF-based application. Just a couple of words about myself. I work as a senior security consultant at Matasano Security. Actually, I would like to thank my colleague for the support on this research. I do love Java. Some people hate Java. I actually do love Java. And this talk is kind of bridge between web application security and Java security, which are my two main focuses. What else? Oh, I'm Italian, although I don't like very much soccer, and I do pay taxes. So what else? I think we can probably get started. I need to provide like a quick overview of AMF. I will try to just do this overview quite quickly and just give you the details you actually need to understand the techniques that I developed and the tool. We will also discuss current techniques and tool, and in particular we will see what are the limitations of those. There will be several demos. Unfortunately, I won't be able to show real-life vulnerability. I prepared a few cases, a few vulnerabilities that were good test cases, and to show the tool. Unfortunately, they haven't been patched yet, so I decided to use a testing application. And nevertheless, I think the application I developed, I modified from a Adobe test drive application. It's pretty good to understand the kind of vulnerability that you may normally find in AMF-based application. Just to clarify, we're not discussing today about bugs in the AMF protocol or the implementation of the actual protocol exchange. We are discussing about finding vulnerability in application developed using Flex and AMF remoting and those kind of technologies. So you're probably familiar with Adobe Flash. Flex is basically an SDK built on the top of Flash technology. And as you probably know, Flash applications are not just shiny interfaces. They may actually be very complex applications with complex and big business logic. And that's possible thanks to ActionScript, which is an object-oriented programming language. Starting from Flash Player 6, Adobe introduced AMF, which is a binary protocol to basically serialize ActionScript objects. And the ActionScript object graphs are basically property in the form of key value pairs. The idea behind AMF is to either save and retrieve application resources locally, or, for example, exchange the data between client and server. It's a binary protocol, so that's definitely way more efficient than text-based protocol. And moreover, as the serialization is natively done by Flex, that actually allow you to reach quite good performance. So for end user, a Flex-based application using AMF looks like just a normal Flex application. But definitely, if you're an old school hacker, if you watch things with TCP dump, you actually recognize that we have a binary blob passing as a in the body of HTTP requests. And if you're a web hacker and you probably use tool like Burp or other proxy, for you AMF is most likely a tree representation with, as I said, value key pairs. And in this particular case, we have a message and an operation, which is in this case is get flags and bin object names. Now, just a quick difference between AMF version 0 and 3. So when Flash Player 6 was released, there was still, ActionScript 1.0. And obviously, AMF was introduced, and it was supporting all the feature of the language at that time. ActionScript evolved and it became actually very complex and modern programming language, and with new data types. And as a result, also AMF evolved. So while releasing Flash Player 9, Adobe also updated AMF specification to version 3, which, as I said, supports new data type, which are the new data types supported by the language. There are also many other differences. One is, for example, that we can send not only object instances by reference, but also traits and strings can be sent by reference between the client and the server. And then there is also support for externalizable, which, if you're familiar with Java externalizable or the .NET externalizable, is basically a way to build your custom serialization and deserialization components. Moreover, we have also, it was actually introduced variable length encoding schema, and all these things are very important if you consider that tools need to parse and process and visualize AMF-based communication. In particular, during this talk, I will be discussing about remoting, so Flex and in the context of RPC. And BlazeDS is basically a very well-known and very widely deployed implementation of a Java server-side remoting technology. And it's basically a way to connect Flex client to legacy backend or complex application on a backend side. So we can have a Flex application or a Hair application, which is an application developed with Flex technology standalone on your computer. Communicate with a server that invokes, in this case, in the case of BlazeDS, Java methods. So in practice, we have clients invoking remotely Java methods from classes which are deployed within a normal application container. So, for example, Tomcat or JBoss, whatever J2E application server. The techniques and the tool I develop definitely work for Java-based remoting server, but actually most of the content can be easily ported to other programming languages and other technologies. So you may have, for example, a Flex client communicating to PHP server-side, to PHP server-side component. And yeah, as I said, most of the discussion we're gonna do today actually apply perfectly for, can be ported easily to those languages as well. Speaking about AMF, for the content of this presentation, we actually need to know that there are several request and responses type. What matters here is the specific type, which is the remoting message that allows, as I mentioned, RPC communication between a Flex client and BlazeDS in this case. Each communication channel can be defined and specified by 3 items: an endpoint, which is an URI, which is basically the entry point for the AMF messages. And then we have a destination server and an operation, which are the equivalent of the Java classes which are exposed by the remote server, and the Java methods, so with arguments and the return value. So we may have, as in the diagram, a client communicating over a channel to a BlazeDS server, and the BlazeDS server has, some classes loaded in the, application container, and those methods are exposed to the public. Now, why is still relevant in 2012, something that, was actually released in 2002? So AMF0 was actually released with Flash Player 6. There have been several research in this field. However, none of those actually focused on coverage and effectiveness of testing. So I will just give you a quick overview of this research and what are the limitations of those techniques, and how I try to overcome those limitations. So the first presentation probably the first presentation for for flash security was performed by Stefano Di Paola in 2007. But actually, 1 year later, here at Black Hat, Jacob and Kevin presented an overview of the security risk introduced by MF3, and in particular about BlazeDS. And they actually define, application that extensively use BlazeDS and expose method and as a very large attack surface, because we are basically exposing, Java methods that should be carefully controlled, and we should carefully do authentication, authorization, and all the normal mechanisms that we have in standard web application. DEFCON 17th, dBlaze was released. It's basically a tool to enumerate and invoke remote methods. I will discuss in a minute the technique used by the tool. Probably the most comprehensive presentation on the topic was delivered by Marcin Wojciechowski during an OWASP meeting in New York. He basically touched several aspects of testing flex application, but the main point for this presentation, from this presentation for me, was we actually need to build custom clients if we want to carefully test application. Most of the time, and especially business-grade application, use custom object, so custom Java object that need to be built and sent over the wire in order to invoke specific method and properly test all the code. As a result, we had also several tools that obviously started supporting the technology, from Burp to Charles Proxy, other proxy, WebScarab. There was a plugin that then was incorporated into the main branch. There is a nice application. I mean, the idea is pretty nice to build Pinta, which is an AR application that you can use for debug AMF messages. So basically testing AMF through a Flex kind of generic client. Unfortunately, there are few functionality and it's kind of limited, but the concept that it is pretty neat. If you go through all this research, you will actually see that the technique used, most of the techniques actually can be summarized into 2 points. The first one is we wanted to inspect and analyze the traffic, and that's normally performed using network packet analyzer or HTTP proxy, Burp, for example. And once we have we have a way to see what's passing over the wire, and we actually have a way to tamper those things. As in normal web application, pen test, we want to do first the enumeration of all the endpoints and parameters and whatever. In this case, we need to do a proper enumeration of endpoints, destination, and operation. And just to remind, destination and operation are basically the Java class and the methods exposed by the remote server. So one of the ideas is why not to retrieve those things from the traffic? Let's just browse the application. The Flex application in our browser, and let's make the application generating all possible messages, and let's analyze and enumerate those messages, which is perfectly fine. But you can already think about some of the limitation. Then there is another idea is we have a Flex application on the client. The Flex application is loaded within the browser, so even in a black box testing environment, we can actually decompile the application because we have the application and get the endpoint from there. Another technique used by dBlaze is brute forcing. In particular for BlazeDS, that's quite good because due to the Java strong typing, we're gonna get from the Java exception a clear indication whether the type we send is somehow the one expected by the remote server or not. So if you're gonna send a string and the server expects an integer, we're probably gonna get an exception, and the message of the exception would easily allow us to understand what are whether the parameter is the argument is correct or not. So if we iterate these things over and over, and we have good word lists, yeah, we can theoretically do brute forcing, and that's equivalent basically when you want to do, for example, brute forcing or RMI endpoints. But it's feasible, but obviously there are also limitations here as well. Unfortunately, life is a pain, and well, if you're doing pen test and you like web application, after a while you are kind of bored because do application, they are interesting, but the kind of bugs you find they are more or less the same. And in this case, we have a binary protocol, so it's big pain, but it's also big fun. Unfortunately, you start using the tool that are out there, and you also discover that some of these tools are not even able to parse, customize messages and messages that use custom Java object. So just to summarize, the technique presented so far are quite good for black box testing because they do not require basically knowledge of the target. However, they are indeed time consuming. So if we want to enumerate, as I said, all endpoints and the operation, we need to browse the the Flex application. We need to use all functionality, try to trigger all possible option, and then dump the traffic and then enumerate the endpoints. That's time consuming. And then there are also several questions. How do we actually handle custom object? So how about a custom object used by the Flex application sent over the wire? How do we discover hidden services? Something that is not used by the Flex client, so you won't see any reference in the Flex client, but it's actually exposed, and the server is there just waiting for someone to invoke those methods. And finally, how to ensure coverage? I mean, if you're doing professional testing, we want to cover all possible endpoints, and we want to carefully test the application. That's our goal. That's our work. Speaking about enterprise-grade application, I mean, we're speaking about very complex application. We're speaking about an application with more than 500 mock methods and can have, more than, 600 custom Java objects. That's the kind of application I've seen and I've tested. So when you're dealing with this kind of attack surface, I mean, you need to carefully, make sure that you're gonna, test those messages and using those objects. The screenshot is basically, from a test drive Adobe application, and that's that it's passing through Burp, and we see there is a custom object which is a product, and as you see we don't have MF tab here. There is no way we can easily tamper the object and send and use the repeater or any other tool, and it's not an issue with Burp. It's like the tool, this kind of tool, have no knowledge of the application objects and everything that is properly customized for the applications. Speaking of security testing of AMF, we basically need to do a parallel of testing web application. So we should be able to build custom object for all methods, so all classes, all methods, and check authentication for those. Make sure that there may be public methods, but there may be some other methods that require proper authentication. And then we need, for example, to test for authorization and access control, which means that we need to build semantically valid messages having customized or arbitrary arguments. So if you want to test for direct object reference, we need to make sure we build a proper object, and we need just to change the ID and see whether with a specific session we can actually access some property or file or resources. We want to also test for error handling, so we want to do fuzzing with a common attack vector and see how the application reacts. We want to test for input validation, so we want to test for SQL injection and LDAP injection. But also we need to make sure that, for example, if the application uses GenAI, we may actually expose the server may actually expose native code over all this technology. So we actually need to make sure to test, for example, for memory corruption vulnerability. In some contexts, also output encoding is important. In the recent version of Flash Player and the entire framework, there was actually a lot of work into trying to limit problematics such as cross-scripting and cross-site flashing. However, in some contexts, it may be still relevant, and so we want to test all those as well. Likely for us, life is not just black and white. And especially if you are doing vulnerability research, you can assume that you can get the application library. So even if you don't have access to the source code, but you're testing like a product or something you actually control, you can actually retrieve and use the application library and application resources. So we can actually use what's normally referred as a gray box testing. So use application resources for helping generating object and proceed further with the test. And based exactly on this idea, I built Blazor, which is a custom AMF message generator with fuzzing capability. The idea is basically to use method signature, the method signature defined in the Java classes and Java reflection to build dynamically valid objects. It comes as a Burp Suite plugin, so and I'm really big fan of the tool. And the idea is I don't want to leave the tool. I mean, I'm very familiar with the tool. I love all the built-in tools that are very useful. I don't want to build something else. I just wanted to use everything from the tool. I wanted to start sending messages from the tool and see things in the tool. It works for both versions, the free version and the professional version of Burp, as the the extension works on both versions, and it actually supports the fantastic new look and feel. It's released as GPL software, and I look forward to your comments, especially if you're interested. Check the code, because as usual, that's the best way to understand how all these things work. To use Burp and Blazor, you basically just need to instantiate Burp as with the other extension. So you add in the class path jar of the extension, and you launch Burp. And in this case, from every basically possible context menu, whether in case there is a remoting message, you can launch Blazor. The basic architecture at the high level is there is a package generator which is based on the Adobe open source libraries for generating the actual AMF messages, and it's I basically wrapped around so that you don't need to specify all parameters and everything. You can easily build messages, and you will see in a second during the demo. The core of the tool is probably the object generator, which the component that makes possible to automatically build objects from the application resources. And as I said, we're gonna, we use Java reflection and kind of best fit the heuristic. Anyway, I will go into detail a bit later during the presentation. Surrounded these two components, we have a lightweight fuzzing infrastructure. So we need to process tasks. We need to generate and define attack vectors. We have a few parameters to tune. So everything is managed by obviously different other components. If you want to look at the code, those are the classes, the main classes of the application. The idea, as I said, was initially to have something completely integrated in the tool. So I really wanted something that I didn't have to, for example, check the standard output or another log file or whatever. I just want to have everything in the tool. So right now and by default, Blazor send messages through Burp itself. So when you launch Blazor, it automatically detects the Burp configuration, the IP and the port, and it sends messages through the proxy itself. So you can actually see messages, requests and responses. However, there are a few cases where you don't want this behavior. If you're testing a very complex application and you're fuzzing that application, you're going to generate a lot of messages. Like I'm speaking about hundreds of thousands of AMF messages. So, I love Java, but I know also the limitation of Java, and I don't want my proxy to crash and lose all the data. So it's probably suggested to have 2 instances of Burp or whatever other tools or whatever other proxy, so that you can actually dump everything while fuzzing and while testing. Or in addition, you may want, or you may have a better tool for displaying AMF messages. A better representation, just the 3 representation you have in Burp or in other tools. So let's start with the demo. We're gonna have 2 demos now. The first one, I'm gonna show you, how to use the tool, and in particular how to generate objects through the tool, and then. I know that people don't want blindly to trust a tool to generate, for example, in this case, object. We need to have a way to customize the object we send. So built in Blazor, there is a bean shell, so you can actually use the internal methods of Blazor to build manually objects and customize and work on let's say that you find a vulnerability, how do you actually write a proof of concept? Or how do you actually build complex proof of concept? That's the way you can do these things. And then we're going to have another demo that I'm going to show you how to discover unauthenticated and exposed operation. Okay, so I have here, it's a test drive application which is provided by the BlazeDS framework and comes with everything packed, already a database with all data. So there are actually different applications. The one I'm using and I actually modified, it's an inventory management. So we can search for things. I don't like fonts, so I wine, and you can search for things, but obviously you can also create new entries. So we can just create a black hat entry, just adding something, and then I'm gonna save this object. Now, obviously, I've been parsing already these things. I mean, I've been proxying already these things. So my browser through Burp, which is already waiting here. And as you see, we have a few things going on. So we have, for example, a remoting message where the service is product service and the methods invoked is get products by name. And if we check the arguments, we see that we are sending a string. In this case, Merlot, which is it was triggered while typing the name. But let's get a bit further. And as we see here, for example, there is no AMF tab, and the main reason is we are sending a product object, which is a custom application object. It's basically a set of attributes, integer, string, and a set of setter and getter to set those properties. So we have name, image, price, those kind of things. And that's obviously our object we see from the raw dump. That's the object we sent. Now Blazor is running, and we can actually check from the alerts box. And the idea of the tool is in every context menu we can just right click and launch Blazor. Now we can do several things here, but the idea is there are four tabs, main four tabs, and that guides the user through the configuration. So first of all, we're gonna add the application library. In this case, just to speed up, I packed all things in a jar. What are these application libraries? That's basically what you find in the web root. Under webinf. So you can even blindly collect all jar and just pack or select all of those, or you can actually investigate a bit further and just to limit. But anyway, that's basically just importing jar or classing or sources. Blazor automatically unpack the jar and it extracts all the public methods that are available. Some of those methods are not actually exposed. I didn't care about selecting and creating a jar with just the the remoting messages. I simply packed all the resources. So we may have here things that are not exposed, but at this moment we don't care, and we will see in a second why. We can actually sort for remoting include only. This is an attribute used in some application to actually specify which methods are exposed to from the server. So we can sort and use those options to filter out all the other one. In this case, this application doesn't use annotation, so we see all methods. We can select all the select. We can select for interface. In this case, we were checking the create product. So we wanna, as I said, I wanna show you how to generate an object. So we wanna do an object generator. There are different parameters here. A number of threads and the number of permutation, which is kind of important things, and I will go a bit more into detail. But it's basically, how many times we're gonna try building an object for a specific method signature. So in this case, let's say let's build 10 objects. We don't want to do fuzzing. Let's just add some other keywords. Black hat 2. So if we get here, we see we can generate 10 objects. So let's leave the tool starting. So the tool is generating object and sending, as I said, through Burp. Now, one convenient thing, we have a fake header, which is not used by the server at all. This is introduced by the tool just for you to basically review what's going on. So we have, this sending a message to product service, to a create product method, sending a custom product. And in this case, we are sending this object. Let me go through these things. So we are sending different objects. So if we check then from here, obviously, we should find something more than, just the bracket. So we see, for example, here we created an object with all this string and the description one example, or the price was 0 and the stock 8. But if we select another, now I don't remember which one I took. You see, it built actually different objects. So that's the idea of the tool. As I said, let's say that you found a vulnerability and you want to do something manually. So you can open again Blazor and just go to the. My bad. First, let's include all the application library, and then let's get back to the bean shell. And the idea here is Blazor has a lot of internal methods which are very convenient for sending messages, and also we can leverage again the application resources to build custom object here. So we can do something like message. And that basically built, the communication object. So we need to specify where to send our stuff. So once again, we want to proxy these things through Burp. And then we need to specify the endpoints of the AMF. Go through these things, which is in this case samples, and then message broker, and then AMF. And then in some cases it may be interesting to specify a cookie. In this case we don't really care. And that's the way how we generate the object used for sending messages over the wire. Then we actually need to build a specific message that you want to send. So for a specific method and a specific class and a specific method. So we're going to build a message skeleton. Now, and I'm using here Java, and that's a bean shell. Some of you may not like these things. You can actually import Blazor jar into whatever language you prefer. If you have a binding for Java. JRuby, for example, or whatever, and then use the language, your favorite language, and basically use the inner methods as well. So we're gonna send a message to the product service, and then we're gonna send. Let's make it simple. We're gonna send a product by name, gets product by name, which basically retrieves a custom object from the application. At this point, we just need to add the parameter of the request. And in this case, let's just get, for example, the black hat object we sent previously. And finally, we just need to send those things. So we send these things. Obviously, this is proxy again through Burp. So we're going to get a get products by name with a black hat. And here we should see, our custom object here. So we can leverage all the application functionality through the tool itself, and even customizing, the way we use and we send packet. Now, let's say that, for example, we want just to do enumeration and discovery. So let's open Blazor once again, just to. Let's clean here. Now, let's say we want to discover which of those methods are actually exposed. So we select again the application functionality. We don't care. We select all methods. We want to generate a lot of messages and see what's going on. Let's improve the number of permutation. Let's speed up, so we won't wait. we will leave the data pools, and we will discuss what's the concept of data pools, which is a kind of very important for the tool here. And we're going to generate messages. The tool is pretty fast, so we can actually see on the standard output, if you want, the tool generating a lot of messages from all endpoints. Some of those, as you can see here, are method not found. So which means that the service is correct, so it is exposed, but that specific method is not exposed. Or we may find, for example, no destination with ID, which show us that those specific service is not exposed. And if you have a pro version, of Burp, you can actually use the built-in tools to filter out. So we can filter out by non-destination ID. And for example, revert here. So we will have all the things that are actually valid. Of course, here we will have also some messages that pertains to method that to messages those methods are not exposed. Now, if we get, for example, through the stuff we got, we actually see that we can sort out by length. And for example, here I added a fake method that is basically a debug service method, which is not used at all by the Flex application. And and uses actually a custom object, which is a string and another custom object encapsulated. And that was probably built by Blazor, and that's a kind of default file that it's retrieved. Now, how does it work? And that's probably the most interesting thing. So the idea is to use, as I said multiple times, Java reflection and a best fit heuristic. Let's think about a custom object such as user, where you have an integer, define a user ID, and a role, which is once again another application custom object. In order to build a proper AMF messages, we need first to build a proper role with semantically valid data, and then encapsulate those custom objects to another custom object built for the purpose of the testing, and send those two objects to the wire. So the idea is let's use Java reflection, and in particular let's use the method of the object itself to populate in a reasonable way the object, and then build the packet and send this thing over the wire. So there are obviously two important things here. It's randomness, which is the the magic sauce for these things. Just change and invoke different methods and randomly choose, for example, the constructor of the object, and do these things over and over and over. And that's the idea of the number of permutation. There are also two important things. One is the data pool. Data pool is basically the idea of containers for good data. And good data here is semantically valid data. So it's data that's relevant for the application, and as a result should be customized in the tool before do actual testing. And using this user good data, we actually build valid object. You may think that's a kind of strong assumption. What we already know what's a good user input, but most likely if we browse partially the application, we're gonna get most of the relevant type for primitive types and string, and that's all we need here. In particular for string, we also have the concept of active vectors. So we have the idea of polluting somehow the string data pool with string that are, they may trigger, for example, input validation vulnerabilities such as SQL injection. We have an option that basically specifies the probability of having an active vector inside the data string pool. And the core techniques are basically, we have different, we iterate through all active vectors, we iterate through all destination and operation. We do these things over and over till the maximum number of permutation, and we generate object and send those object. How do we actually generate the object? So if it's the string signature is, corresponds to a primitive type, we just assign an object from the data pools of the specific primitive type. Otherwise, we use Java reflection again to go through the object And as we have application resources, so we can, go further and, retrieve things from the application library and build even customized object. So let me provide you an example. We have a method that gets an hash map that basically retrieve a string that is used subsequently in a SQL query to specify a column. Now it's a kind of, it's a simple code, but there is a narrow condition that you would be able to build a proper hash map that's gonna trigger any SQL exception. It's clear if you see the code, but in a black box testing, you may actually need to generate a lot of things before you actually end up generating an hash map with a key as key. So how Blazer actually would work in this situation? So the first things, obviously the object has the string signature of the method, and in this case it's Java-util hash map. So the first thing that Blazer does is iterate through the constructor, randomly choose one of the constructor. In this case, we got the second one that requires an integer as an argument. So again, Blazer will use the signature, and from the data pool of integer, select randomly one of the integer. In this case, 2. So the result after this process is we have an hash map, a properly built hash map with 2 items. Next step is let's remove and let's comment out all the methods that have no arguments. And the main reason is we want to build valid object, and most likely the object itself, because of the way developers write things in Java, and because of the way, for example, the Java Bean specification is made, we have methods that allow you to populate attributes. And those methods actually require an argument. So in the Java Bean specification, you would have a setter, which is set name of a property, and as a parameter, as an argument, you'd expect the property itself. So we comment out all the methods with no arguments, and we're gonna choose a series of methods, not just one. In this case, I simplified, and I got directly to the good one, but it's gonna iterate and try multiple methods, and then again iterating through the arguments. In this case, object we map to string, which is the most likely to have useful to build attack vector, for example, and we select from the string data pool to string, and at this point we have an hash map with a foo equal bar and then a null item. So that's the way how the object generation is performed. So let me show you these things. That's fuzzing, so it may get these things pretty quickly, it may not. I'm positive. So let me select again Blazer. Actually, let me close this instance. We're gonna select again the application library. This is the method we want to fuzz get product by hash map. This time we want to do a bit more permutation. I want to be quick. Let's leave the attack vector probability, which is, as I said, a way to pollute the data pool string. We can import attack vector from word list loading a file, but we can just simply type any kind of attack vector you may want to use. Just to speed up, let's reduce maybe the string. And obviously, that should be customized for the application. As I said, it may sound as a strong assumption, but if you browse for the application for a while, you would be easily able to build a set of primitive type and string that are relevant for the application under scrutiny. So we have a set of methods to fuzz. Let me clean up here. Now, the tool is generating stuff. If you see from here, we're actually generating, hashes, different way. Some have null, some gets, get trigger exception. And if we get back to Burp, let me try to filter out. Oh, for example, here's one. We already get, we were passing example, so it's not a valid. It's not a valid column, and that's actually trigger SQL exception. We can once again filter from using the built-in tool. So we'd actually see here, a few messages that are still generated by the tool. Now, obviously there are some limitations, and the main limitation is about time. Theoretically, you could iterate and generate object. We are using the same method of the application to build valid objects. So if the data pool is properly personalized and customized for the application, and we iterate this thing as many times as it's required, depending on the application complexity, we will actually be able to automatically generate valid objects and then valid AMF messages for all exposed methods. But this is obviously, a matter of, customizing Blazor in a proper way, choosing the proper number of permutation, and balance the good and bad actor vector. Let's think, for example, an application that has control over the place, and the developer just missed one point where a string is not properly validated. We want to make sure that in all other cases, so in all other strings, we have valid data, so just simple strings, and then in that specific occurrence, we have, for example, a quote to trigger a SQL injection error. So that requires a lot of iteration and a lot of trial and error. And during big assessment, time matters. Time matters because if we consider, for example, a quite big application, 500 exposed methods, and the relatively small attack vector, so Burp default fuzzing list in the intruder, which is the one you can normally select, it includes 45 items, which is probably not even enough to have a good attack vector list for all SQL injection. So if we want to do proper testing, we need to increase quite considerably the attack vector used to generate object. And even in case of 45 attack vectors, and with an average of 35 permutation, which is more or less something I determine experimentally, but it's a good approximation of how many times you need to try to build complex object. And let's assume a setup with a laptop that you're running Burp and Blazor and the server, remote server for testing. That's going to take already 3 hours, almost 3 hours. So if we increase 4 times the attack vector, or even more if we want to make sure that we have all the attack vectors in our word list, that's going to take a while. And that's only the time used to generate object. So we need also to consider the time then required to parse and filter out and comment out all the irrelevant message and exception. So back to the security testing methodology, how we can modify those testing methodology with the tool we have now. So for example, authentication. Most of the cases, authentication for BlazeDS application is managed by the standard session ID, so a cookie. And what we want to do is basically, generate valid objects, send, valid AMF messages for all endpoints, for all messages, for all, possible exposed methods, and verify whether they're accessible or not. So we can use Blazor with object generation and build as many objects as we want, and then understand the results by filtering out or sorting the responses. In case of, for example, of checking for direct object reference bug, we want to once again build valid object. We may want, for example, to use a repeater to change the session ID for different session and roles on user. But we also want to customize the string data pools or integer data pool with values that are relevant for the application. So if we have an application which is a catalog and there's IDs which are the different items, we want to add in the integer data pool all the valid item and see if, for example, with a specific session token we can access all of them, some of them, and those kind of things. And for error handling and input validation, you can use your favorite word list, import in the tool, and start fuzzing. And then again, sorting responses by sites, which, I mean, I guess that's what normally people do also for web application security testing, standard web application security testing. Filtering research by term, or, you know, in case of exception, and those kind of things. Also, it may be relevant for you if, you know, you want to speed up the processing. It may actually be beneficial to have something more that you can use to parse the responses. And that's actually something planned for the future. So wrapping up, the approach and the tool has been proven to be, you know, quite good for increasing the coverage and effectiveness of finding vulnerability in BlazeDS, you know, AMF-based application. And, you know, the idea was not only to have an easy tool, but also something that could be used by, you know, professional pen testers to then personalize the payloads and the actual proof of concept. So you can actually import Blazor resources, so, you know, the jar, and use the expose methods. Now, there are a few improvements that I'm thinking and I am actually already developing. Two upcoming are the possibility to import also source code and classes directly from directory, you know, recursively from directory, not only jar, which, I mean, it's an obvious feature. Another improvement, which is going to be released pretty soon, it's the idea of sandboxing the object generation. So we are using application library. And, you know, testers may not be using a virtual environment or a PC just for testing purposes. They may use, you know, their laptop. So we actually don't know what the methods are gonna do. The application methods are gonna generate. So we may have, side effects such as, file generated on a file system, that kind of stuff. So to prevent these things, we can, people can already use Java security and the normal Java security manager, but I would like to implement something that basically gets out of the box sandboxing for the object generator class. And I got some feedback from my colleague, and a couple of the ideas were to have a tool for displaying AMF messages within the tool. So sometimes it's very difficult, especially with complex objects, to understand what's the actual structure. So it may be beneficial to have something that is able to show a 3D view of also customized object. And you can speed up, for example, the selection of method signature by selecting methods which are already parsed and processed by the application and are already in Burp. So if we have endpoints they were properly invoked in Burp history, we may want already to have a tool selecting those methods. That's basically my presentation. If you have any question, we have 2 more minutes. And so I can answer your question now or later, or by email or Twitter or whatever you prefer. Any question? Yep. You can limit the number of threads. So the endpoints is actually automatically retrieved by Blazor while selecting a specific message. So the endpoint is basically the entry point for all AMF messages. And what matters in terms of invoking the remote method is basically selecting the right service and the right operation, which are the equivalent of classes and method. So if I understand correctly, your question is, I can, when I select Blazor here, Blazor has already knowledge of cookie, for example, or custom headers, or the endpoint. So what we need to do is just define the other properties, so classes and method. And then, yes, the only way to slow down is basically to limit the number of threads, and you can do everything from the tool, from the GUI, but definitely you can use, standard output is actually used for dumping raw Java objects. So I built, using once again Java reflection, methods to unpack Java object and display those objects, which is the one, which is basically part of what you see here. So that's the way how you see, what's the class and the method. I don't know if that answers your question. And okay, so the question for the recording is like, how do we actually slow down, and how do we actually select the endpoints of the request? Any other question? Thanks a lot.